I really messed up the original for this problem, so I'm going to redo it here in a new video. So I'm going to find the second derivative of this function here. And after I find the second derivative, I'm going to find what x makes it 0. So to find the second derivative, of course, the first thing you need to do is you need to find this first derivative. Since this is you're going to have to either use the product rule or the quotient rule for this. I'm going to use the product rule. I'm going to say that u is x, and I'm going to say that v is equal to x squared plus 2 to the negative 1. It's a little trick to use the product rule instead of the quotient rule. And so u dashed is equal to 1. V dashed is equal to negative times x squared plus 2 to the negative 2. Now don't forget to take the chain rule here. I often do. It's going to be times 2x. Okay. Now I'm going to substitute in for the product rule here. So u dashed is 1. V is x squared plus 2 to the negative 1. U is equal to x, and v dashed is equal to negative 2x times x squared plus 2 to the negative 2. Now I'm going to write everything out with denominators. X squared plus 2 plus, let's see, that'll be negative 2x squared over x squared plus 2 squared. I'm going to put everything over a common denominator. X squared plus 2 squared. X squared plus 2 minus 2x squared. Now I'm going to simplify a little bit. Look, I got x squared and I got an x squared. I'm going to combine those. I'll have a negative x squared and I'll have a positive 2. And then on the bottom I'll have x squared plus 2 squared. Okay, so that's my first derivative. Now for my second derivative, I'm going to use the quotient rule. It's getting a little bit hairy to do the product rule. So I'm going to make the numerator equal to 2 minus x squared. The denominator is equal to x squared plus 2 squared. And if I want to take the derivative of v, it would be 2 times x squared plus 2 times the chain rule to x. Okay, now I'm going to put all these into the quotient rule down here. So u dashed is negative 2x. V is going to be x squared plus 2 squared. U is going to be 2 minus x squared. V dashed is going to be 4x times x squared plus 2. And in the denominator, we're going to have v squared, which is going to be x squared plus 2 to the 4th. Okay, now we're going to cancel out some things. So, for example, here we have x squared plus 2, x squared plus 2, x squared plus 2. So we're going to get rid of 1x squared plus 2 from here, 1x squared plus 2 from here, and 1x squared plus 2 from here. And then we'll end up with to the first, to the third, and to the nothing. Okay. So that's going to give us, let's see, negative 2x times x squared plus 2 minus 2 minus x squared times 4x divided by x squared plus 2 to the 3rd. Now we're going to have, let's multiply everything out. We're going to have negative 2x cubed minus 4x. And then we're going to have minus 4x times 2, which is negative 8x. And then we're going to have negative of negative x squared times 4x, which is going to be positive 4x cubed. All over the denominator x squared plus 2 cubed. Let's combine some like terms. So like there's a like term. There's a like term. Let's total them up. So that would be 2x cubed minus 12x divided by x squared plus 2 cubed. And then we want to know, when does that equal 0? What are the x values that make that 0? So we're more concerned about the denominator because the denominator is what is going to make it 0 or not. Let's factor out a 2x. That's a common factor. We'll have x minus 6. Oops. X x squared minus 6 equals 0. So an x equals 0 will make that 0. What else will make it 0? Let's see, x squared equals 6 will make that equal to 0. X is equal to plus or minus the square root of 6. So those are the three roots right there that will make the second derivative equal to 0.